So lesson number 4, we're again working with operations of functions, and this time we're looking at the quotient of two functions. So two functions, f of x and g of x, are defined for all real numbers. The functions of the graphs are shown on the grid. The points marked with the dots have integer coordinates. So when x equals 4, f of x is equal to 14, and g of x is equal to 2. So 14 and 2. So then if I look at the quotient, I get 14 divided by 2 is 7. So I want you to go through this column and complete it, and complete the quotients. And then we'll look at graphing it afterwards. So we'll follow the steps in order this time. So if we go through our values for f and for g and we divide, the only one that becomes tricky is when x equals 2, because I get 0 divided by 0. I cannot divide by 0, so this one we write down as being undefined. So that's how we express something that, okay? So it says, explain why the domain of the function of the quotient of the two functions is not an element of the real numbers.
Because you have that point at 2 that's undefined.
Right. So when x equals 2, g of x equals 0, and we cannot divide by 0. So which means in the function, f divided by g of x, when x is equal to 2, the function is undefined. So it says, sketch the function of this graph, showing the domain restriction by drawing an open circle on the graph. So in other words, what that means is if I start graphing this, when x equals 4, or the quotient function is equal to 7. When x equals 3, it's equal to 6. When x equals 2, it's open. That's where I put the open circle in. When x equals 1, I've got 4, 3, 2, 1, 0, and negative 1. So when I go to draw this line this time, I would have the line that goes up to the circle and then extends from the circle. And I'd have my arrow marks on either end. So then the next part asks us to find the equation given the two equations. So find the function notation given the two functions. So I have x squared plus x plus 6 divided by x minus 2, that would be minus 6. So how do I divide the two functions? This was rational functions from last year. How would I simplify this? So what could I cross out?
Could you cross out the square?
I can't cross out terms. I can only cross out common factors. So x minus 2 is a common. I need to factor the top out. So when I factor the top, what do I get?
Probably x minus 2.
Probably x minus 2 times x
Plus 3.
plus 3. two numbers that multiply to negative 6 and add to positive 1. So now I can cross out the common factors of x minus 2, which leaves me with x plus 3. But I have this domain restriction in that x cannot be equal to 2. Because when x is equal to 2, the bottom is equal to 0. So I have that in for my domain restriction. Okay? So then if I evaluate f divided by g of negative 6, I would put in negative 6 where I see x in my simplified equation. Negative 6 plus 3 becomes negative 3. So at the top of the next page is just another explanation about that the graph of the quotient function cannot include the point 2 and 5 because there's a domain restriction. So what I get is I get a hole in the graph, and that hole in the graph is called a point of discontinuity. And we'll talk about points of discontinuity in more detail when we do the rational chapter later on in this course. In this investigation, the quotient of a quadratic and a linear function simplifies to a linear function with a domain restriction. That's not always the case. There's a multitude of examples where a quadratic divided by a quadratic could still leave me with a different type of function. It doesn't necessarily have to be a linear function, and it doesn't necessarily have to be a function that has a domain restriction either. Okay? In each case, write and simplify where possible an expression for f divided by g of x. Include any domain restrictions. So this goes back to what we did last year with our rational functions chapter, or rational equations chapter, when we were solving and we were finding the roots of rational equations. So I have 2x plus 5 divided by x plus 5. So I can only cancel out factors. I can only cancel out common factors. So are there any common factors in this equation? The 5 is a common term, it's not a common factor, because that 5 is tied to the x. So then what are my restrictions? What can't x equal? Negative 5. So if I look at B, with the x squared minus 2x minus 35, let's start off by factoring that. Can we factor that quadratic? So two numbers that multiply to negative 35 and add to negative 2. Negative 7 and 5. So I get x minus 7 and x plus 5. So I can cancel out the x minus 5, or sorry, the x minus 7s. So I get x plus 5 for my simplified equation. Do I have a domain restriction? Do I have a value that x can't equal? X can't equal 7. Because if it equals 7 in the original question, I'm going to get divided by 0. If I look at at C, x minus 2 divided by, can I factor x squared minus 5x plus 6?
X minus 3, or x minus 3 and x minus 2.
Okay, so then my factors cancel. What does that leave me with for the numerator? 1 over x minus 3. And what can't x equal? 3 and 2. So it can't equal both values, because both values in that equation will result in a 0. Okay. If we look at class example number 2, it says, consider the following two functions. What are the domains of f and g? So if I look at f, I have a quadratic function. Is there any value of x that you can think of right now that I could not put into that equation? No. What about into g? So the domains of f and g is that they're real numbers. So now if we simplify this, so we want f divided by g of x. So g of x is 2x plus 1. So then on the top, if I go to factor this, take a wild guess as to what one of my factors probably is. 2x plus 1. And that can actually be useful because it can help me factor for the rest of it. So what do I multiply by 2x to get 2x squared? X. And what am I going to have to multiply by 1 to get negative 7? Negative 7. And then I can do a quick double check with my outside and my inside because that gives me my middle term. Negative 14 plus 1 gives me my negative 13. So if I cancel out my common factors, I'm left with an x minus 7. But what can't x equal? Negative 1/2. And I can figure that out by letting 2x plus 1 equal 0 and then solve. So I subtract by 1, there's my negative, divide by 2. What are two ways that I can evaluate this function?
You could put in the 3 like before you cancel out a term.
Okay, so I could substitute 3 into the original, then divide. What's the other way? Yeah, so substitute 3 in the simplified function. So which one do you want to do? In the simplified? So f divided by g of 3 will equal 3 minus 7, which equals negative 4. Okay, so I am going to give you question number 1. 3A and C, and number 5. So last class we were looking at operations with functions, and we were looking at the product and at the quotient. So this class we're going to finish looking at the quotient of two functions. So it says, consider the functions f of x equals 2x over x minus 1, and g of x equals x over x minus 3. So if we state the domains of f and g. So if we look at the domain of f. So if I look at my equation for f, what I need to determine is, are there particular values that x can't be? And if I have a rational equation, like a fraction, what do I know about the bottom part of my fraction? Can't equal 0. So when is this going to equal 0? If x equals 1. So my domain is that the set of x values such that x can't equal 1. But it could equal anything else. So it could be an element of the reals. That would be my domain for f of x. If I look at the domain for g, what can't x equal? Actually, Mrs. Allen, I do. What can't x equal? 3. So x can't equal 3, but x could be an element of the real numbers. So if we evaluate this following expression, what does this mean?
multiply that.
Right. So in this case here, which is going to be easier? To multiply these two functions together first, or to put 2 into the two functions and then multiply them together?
I'd say put 2 in.
Because I don't have the equation already simplified, it's going to take the same amount of time regardless. Only if I put a 2 into these two equations, I'm less likely to make mistakes because I don't know what the simplified would be. So this would be taking 3 times f at 2 times g at 2. So I have 3 times, and then if we look at f at 2, 2 times 2 over 2 minus 1. And then 2 over 2 minus 3. So 2 times 2 is 4, and 2 minus 1? So 4 divided by 1? 4. And then 2 minus 3? Negative 1. So then 2 divided by negative 1? So 3 times 4 times negative 2 is negative 24. Okay. Question C, again, asks you to do what? What are you asked to do in question C?
Add the 2 statements.
Add the two statements together. So we have 2x over x minus 1 plus x over x minus 3. How do I add rational expressions? Make the denominators the same. So how do I make what would my common denominator be?
Go ahead.
Okay, you go.
Okay, x minus 1, x minus 3.
Okay. So if my common denominator is x minus 1 times x minus 3, what do I need to multiply my first rational expression by? X minus 3. And what do I multiply the second one by? Okay, I'm going to give you a moment. I want you to simplify it. Okay, so if we expand this out, I get 2x squared minus 6x plus x squared minus x. So that gives me 3x squared minus 7x over x minus 1 and x minus 3. From the top, we could factor out an x to get 3x minus 7. And again, I'd have to put in my conditions that x can't equal 1 or 3. Okay. If you had left this as 3x squared minus 7x, I would probably mark it fully, even though the question does say in simplest form. So if possible, if you can easily factor out the top, you should try. Just in case, sometimes when we do that simplification, factoring out the top may also have a common factor with the bottom, and then you can do more elimination. That would be the only reason why I would say to make sure to factor, to look at the top to see if it can be factored. If it can't be factored nicely, then don't worry about it. And then question D says write an expression in simplest form for the quotient of the two functions. So the quotient of the two functions is 2x over x minus 3 divided by x over x minus 1. How do I divide rational expressions? Invert and multiply. And we invert the second expression. Is there any factor, common factor, that I can cancel from top to bottom? I can factor out or I can cancel out the factor of x.
Is it mixed up, like the 2x, is that supposed to be over? I think it's supposed to be over.
Oh, sorry, I have it written down wrong?
Yeah.
Okay. I was trying to go by memory. Apparently my memory is not very good today. So this should be x minus 1
Yeah.
and x minus 3?
Yeah.
Okay. I can still cancel out the x. And then when I multiply, I now multiply straight across. So I have 2 times x minus 3 over x minus 1. Now, what are my non-permissible values? What can't x equal? 3, 1, and 0. So the 3 and 1 are the same from the previous question. Where does the 0 come in? When I inverted and multiplied, this x became on the bottom. So before I cancel out any factors, I have to see if this is a non-permissible first. Okay? So the questions that I would like you to work on, I think I gave you 1, 3, C, and 5, right?
Yeah.
Yep.
So then 8, 10, and 11.